Hey there, Seahawks. It's Miss Adams, and in this video, we're going to go over an introduction to confidence intervals. All right, so statistics is all about answering questions, and because it's often too difficult, too expensive, or impossible to ask everyone in the population, we take a sample and we use the information we collected from the sample to make predictions. Of course, by taking a sample, we can't be certain of our estimations. Inference procedures, such as confidence intervals, use probability to show how strong our estimates are. All right, so we're going to go over some important vocabulary and formulas and their definitions. So confidence level is the percentage, so sometimes we'll use capital C or capital C %, how often the true percentage of the population would pick an answer that lies within the confidence interval. There's not really a formula for this, but the typical confidence levels that we use in statistics are 90%, 95%, and 99%. Confidence interval is usually written as a range of values from A to B. A would be your lower value, B would be your higher value. It uses statistics of observed data to estimate the true population proportion by giving a range of plausible values. And the general formula is your statistic plus or minus your margin of error. And we'll get into specifics when we're talking about the type of data you're collecting. Your point estimate is basically the value in the middle of your interval. So a single value estimate for the population parameter. We find this by taking your highest value and your lowest value and adding them together, and then dividing it in half to see what would be that value that's right in the middle of your interval. The margin of error, we abbreviate as MOE or just capital E, is the greatest possible distance between the point estimate and the value of the parameter it's estimating. So basically you have your point estimate, and then you have this plus or minus these margin of errors that give you your interval. All right, so your margin of error, if you're working with proportions, is Z star times the square root of P times 1 minus P over N. And if you're working with means, it's T star times SX, your sample standard deviation, over the square root of N. Your critical value is either going to be Z star or T star, depending on the type of data you're working with. Values that separate sample statistics that are probable from sample statistics that are improbable. All right, to find these, we would use a table or our graphing calculator. And then the standard error is SE, is how it's abbreviated, the standard deviation of its sampling distribution, or an estimate of the standard deviation. Basically, you're finding the standard deviation from a sampling distribution, and we call that a standard error. So that would be the square root of P hat times 1 minus P hat over N when you're working with proportions, or the sample standard deviation over the square root of N when you're working with means. All right, Miss Adams is curious about the proportion of students who use TikTok. She takes a simple random sample of 200 students and constructs a 95% confidence interval to estimate the true proportion of students who use TikTok regularly. Here's the interval. So the interval is from 0.82 to 0.90, so 82% to 90%. Interpret the confidence interval. What is the point estimate and what is the margin of error? So if I'm interpreting this confidence interval, I know that it was a 95% interval, and I know that the interval went from 0.82 to 0.90. So we have to make sure that we put this in context. So this was about the proportion of students who use TikTok. So we are 95% confident. The true proportion of students who use TikTok is between 82% and 90%. So that's how we're going to word our interpretation of the interval. What point estimate was used? So I'm going to take my lowest value in the interval plus my highest value in my interval and divide by 2 to find the value that would be right in the middle, which gives me 0.86. What is the margin of error? So the margin of error is telling me how far is the point estimate from the highest value and the lowest value. So I'm going to take my lowest value and I'm going to subtract the middle value, and I'm going to get negative 0.04. That's how far it is from my lowest value to the point estimate. And then I'm going to do the same thing for my highest value minus the point estimate, and that gives me positive 0.04. So that's how far it is from the point estimate to the highest value. So my margin of error is plus or minus 0.04. All right, go Seahawks.